All right. So now we see that there's a clear link between the pressures and the temperatures, and we figured out a delta T, and ultimately we can keep going, use the ideal gas law, use the definition of the change in enthalpy, TDS plus VDP, and TDS, of course, is going to be 0. And we can combine these equations to ultimately find what we're looking for. Let me see here, I have it written down. Is going to be a relationship between temperatures and pressures. So it's going to say that T2 over T1 equals P2 over P1 to the gamma minus 1 over gamma. There is a full derivation of this in the lecture notes that are posted on LMS, so if you're interested, hopefully you are, you can follow along with the lecture notes, and then if you have any questions, absolutely contact me and I'll help you out. But this is what we're looking for, right? If we kind of return back to the solution we had this exit velocity as a function of temperature, essentially, or we kind of crafted this as a temperature change because it was interesting to think about. But we want to get the handle of this exit velocity and rewrite it as a function of pressures instead of temperatures. And so now we see that if we have a temperature ratio, if we can write this as a temperature ratio, we're going to be able to correlate that to a pressure change.